The model used was graciously provided by Ascension Group Architects, Layton Construction, and Structural Detailing out of Tennessee. The project consists of 8,483 members with 5,860 stairs and lintels, hangers, and pour stops. To speed things up, I'll begin by isolating only a few sequences of this project. At this point in time, I'd like to mention that you can import 2D drawings, for example site drawings, and 3D items such as walls and obstructions into the SDS2 model. You can also modify these imported drawings. Time to talk about cranes. The crane tool is designed to assist a competent professional, not to replace one. We support the following crane types: tower, crawler with a fixed and luffing jib, truck, all-terrain and rough terrain with lattice and telescopic booms with both fixed and luffing jibs. Let's open the crane tool screen. Then I'm going to open the crawler lift configuration. Here we have the available crane configurations for the crawler crane manufacturers. You can add in your own crane configurations so long as they match the types available. I'm going to select the Manitowoc 14,000 to give an example. We can see a vast number of boom configurations, and the data burrows all the way down. For example, the parts of line capacity. This is required to get accurate hoist capacity results. As you can see, we've added all the boom configurations available for this Manitowoc 14,000. If you were to add in your own crane configuration and type, you would only need to add the configurations that are available. Here is where your expertise come in. You'll need to choose the crane you intend to use, then test the crane's capacities using SDS2. There's more to a lift than just reach radius. You'll have to determine timeline for the erection of the project. Trucks and crawlers can be in and out of the site quicker than a tower crane. Project size, height of structure, high rises, of course, will require generally tower cranes. Availability of cranes. In some cases, you are restricted by the available cranes in that location at the required scheduled time. Available travel space for the crane during erection. Can the crane travel to positions that allow you to set the steel? The soil and terrain of the site. We don't perform the ground pressure evaluation. We leave that to the crane manufacturer. In the case of crawlers, is there enough space to assemble the crane? The maximum load to be lifted on the project. Well, we do handle that part, at least from the fabricated steel side of things. As a reminder, I'd like to mention how accurate the fabrication model is, including the assembled weight of the members. We even include the weight of all the shop bolts. I will run this report on the selected members. Of course, you'd perform this operation on the entire structure. We see that the member 34C1 has a greatest member weight at 19,000 pounds. I'll use the model tree to find and locate this member. Then I'll go ahead and save this selection as heaviest member weight, just for later reference. On a side note, the model tree is a great way to locate that needle in a haystack. For example, an embed. And it also tells you how many members there are indicated on the right hand of the text. I've determined that I would like to assemble this lintel here on the ground and then lift it. I'll determine the weight and the center of mass, locating a point from where the center of the mass will be taken from. We see the location and weight, and if I want, I could add a note to the assembly with this data. I will save this selection for later use, naming it assembly number 1. Please proceed to Part 2 of the cranes.